In this video, we're going to look at another application of solving for the volume of a revolution by applying the washer method. The question here is to find the volume of a solid obtained by rotating a region bounded by the curves y equals 1 over x and 2x plus 2y equals 5 about the line y equals negative 1. The first step, as always, is to find the points of intersection. We're going to substitute y equals 1 over x into 2x plus 2y is equal to 5. So we get 2x plus 2 times 1 over x, substitute y in, equals 5. Multiply both sides by x, we get 2x squared plus 2 equals 5x. Now to solve this, we should bring it all to one side, and we get a quadratic equation, quadratic function I should say. Then we can apply the quadratic formula to solve for the roots of this function. So we have 2x squared, bring everything to one side, plus, actually we get 2x squared minus 5x plus 2 equals 0. The quadratic equation is x is equal to negative b plus or minus root b squared minus 4ac divided by 2a. And you should always write it in the form ax squared plus bx plus c equals 0. So you can plug in the right values for a, b, and c to solve for the roots. X is equal to negative b minus 5, that's 5, plus or minus root b squared, that's 25, minus 4 times a, that's 2, times 2, all over 2a, that's 4. So we get x is equal to 5, plus or minus 25 minus 16 is 9, root of 9 is just 3, divided by 4. So 5 plus 3 is 8 over 4 is 2, 5 minus 3 is 2 over 4 is 1/2. These are the x values, x equals 2, x equals 1/2. We plug it into y equals 1 over x, and we get y is equal to 1/2. Plug it into y equals 1 over x. We get y is equal to 1 over 1/2 is 2. So these are the coordinates of intersection, x and y coordinates. The next step is to sketch the bounded region and a typical washer. Let's first solve for y in terms of x. So we have 2x plus 2y equals 5. Isolating 2y, we get 2y is equal to 5 minus 2x. Divide both sides by 2, and we get y is equal to 5 over 2 minus x. Now, the most important thing is that we have the radius of rotation defined properly. So the outer radius is a distance from the axis of rotation, which is y is equal to negative 1, is a distance from the axis of rotation, y equals negative 1, to the farthest point on the rectangular slice that we've drawn. This slice here, this red slice. So we're looking for the distance from the axis of rotation to the farthest point on the rectangular slice. And that corresponds to the y value corresponding to the line y equals 5/2 minus x. That's the top point of contact. So we have 5 over 2 minus x minus 1 will give you the outer radius. This is the outer radius, and we get 5/2 minus x plus 1. Now, what about the inner radius? The inner radius is a distance from the axis of rotation, which is y equals negative 1, to the closest point on the rectangular slice. The bottom point of contact is the reciprocal function y equals 1 over x. So y equals 1 over the distance from y equals 1 over x to y equals negative 1. So radius inner is going to be 1 over x minus 1, that's 1 over x plus 1. So take a moment, look at this entire diagram, and make sure you understand that what the outer radius is and what the inner radius is. You always should remember that the slice that we draw is perpendicular to the axis of rotation, of course. And you should also remember that we're on a coordinate system. So we're looking at two things, the y value corresponding to the line y equals 5/2 minus x, and the y value corresponding to y equals 1 over x. So again, the outer radius is a distance from the axis of rotation, which is y equals negative 1, to the farthest point on the rectangular element, which is the line y equals 5/2 minus x. The inner radius is distance from the bottom point of contact, which is y is equal to 1 over x, to y equals negative 1. And hence, that means 1 over x minus 1. That's the outer radius, that's the inner radius. We can now form the integral and solve. All right, so let's write these down. The radius outer is equal to 5/2 minus x plus 1. Radius inner is equal to 1 over x minus 1 is 1, that's plus 1. The washer volume is going to be differential volume is equal to pi times, let me write this here, give ourselves some more room, dv is equal to pi times 5/2 minus x plus 1 all squared minus 1 over x plus 1 all squared, close the bracket, dx. So this is a cross-sectional slice of one of the washers, and we've drawn it here. And basically, with this technique, you're subtracting the inner radius, the area of the inner radius, and that's why it's called a washer method. And so it's always the inner function, the distance from the inner function to the line about which you are rotating about, in this case y equals -1, that forms that inner radius. And by subtracting the area of the inner radius, we basically find the volume of the solid. All right, so let's put it into a definite integral. Volume is equal to pi. Integrate from 1/2 to 2. These are x values from x equals 1/2 to x equals 2. Outer radius squared, we get 5/2 minus x plus 1 all squared minus the inner radius 1 over x plus 1 all squared dx. We can simplify this. 5 over 2 plus 1, that's 5 over 2 plus 2 over 2, that's 7 over 2. So let's change that to 7 over 2. We can just do a bit of simplification. 7 over 2 minus x. Outer radius squared minus inner radius squared times pi, integrate, and we'll get the volume. So the next step is to set up our definite integral. We've done that, but we're going to do it again for the sake of revision. Volume is pi, integral from 1/2 to 2, 7 over 2 minus x all squared minus 1 over x plus 1 all squared dx. Volume is equal to pi. Integral from 1/2 to 2. I'm going to open up this bracket here. 7 over 2 minus x all squared. 7 over 2 squared, we get 49 over 4. Minus 2 times x times 7/2. That's 2 times 7/2 times x plus x squared minus 1 over x squared plus 2 over x plus 1, close bracket, dx. So volume is equal to pi, integral from 1/2 to 2. And we have, let's open this up further. We get 49 over 4. 2 cancels with 2. We get minus 7x plus x squared. Distribute the minus sign. We get minus 1 over x squared minus 2 over x and minus 1. Integrate all of that with respect to x. Now, if we simplify this a bit further, 49 over 4 minus 1, that's 49 over 4 minus 4 over 4, that's 45 over 4. So we get 45 over 4 minus 7x plus x squared. We'll rewrite 1 over x squared as x to the power of minus 2 to make it easy to apply the reverse of the power rule. Minus 2 over x. All integrated with respect to x. So we integrate from 1/2 to 2 times pi. That gives us the volume. And now let's do the integration. Volume is equal to pi times, integrate 45 over 4, that's just a constant, we get 45 over 4x, minus integrate 7x, we get 7x squared over 2, plus integrate x squared, reverse the power rule, we get x cubed, divide by 3, minus integrate x to the minus 2, that's going to be x to the minus 2 plus 1, that's negative 1, divide by minus 1, and integrate 2 over x, we get 2 log x. Apply fundamental theorem of calculus, integrate from 1/2 to 2. Alright, so we have volume is equal to pi times 45 over x minus 7x squared over 2 plus x cubed over 3 plus 1 over x minus 2 log x. Evaluated from 1/2 to 2. Apply fundamental theorem of calculus, putting the upper limit in. Let me just make some corrections here. This is 45 over 4 times x. Sorry about that. So pi times Plug in the upper limit in. 45 times 2, that's 90 over 4 minus 2 squared is 4 over 2 is 2 times 7 is 14 plus 2 cubed, that's 8 over 3 plus 1/2 minus 2 log 2 minus pi times, plug 1/2 in, we get 45 over 8 minus 7 over 8 plus 1/2 cubed, that's 1/8, we get 1 over 24 plus 1 divided by 1/2, that's just 2 minus 2 log of 1/2. And we close the bracket. Now, if we do many more steps of simplification, we're going to get volume is equal to pi times 39 minus 32 log 2 divided by 8. And this is approximately 6.6. So we've done many of these washer type questions, and the reason for doing so many of them is really to get practice at defining the outer radius and inner radius, and maybe also some practice with integration. But the most important thing is getting the right radius of revolution. So I want you to look at this one more time and just decide for yourself that you understand what the outer radius is and what the inner radius is. So again, the outer radius is the distance from the y value corresponding to the line y equals 5/2 minus x, is this distance here, and the distance from the y value corresponding to 5/2 minus x to the distance to y equals minus 1. And the inner radius is the distance from y equals 1 over x, the bottom point of contact, to y equals -1. And that forms the outer radius and inner radius. Once you have that, it's just plugging into the integral and solving for it. After that, it's not too difficult. But this is the most important step. All right, thank you.